The question is, I'll just write down a question. Can you see I'm writing? Is it on the top? I just have written a mark. So, okay, you can see, right? Can you see now? Okay. Oh, okay. So evaluate the double integral over the region R, x into y dx dy, where R is bounded by this one, that is x squared divided by a squared plus y squared by b squared equals to 1, and the straight line. So the straight line is x by, no, sorry, x by a, my mistake, x by a plus y by b equals to 1. This is the right. So let's try to draw the required diagram first. Okay. Now I know that I'm actually interested in this region, right? The whole ellipse is going to look something like this, maybe. This part you are comfortable? Yeah, no problem. Absolutely fine. You can draw only the first quadrant. Okay. So if you feel comfortable with that way, please go ahead. Okay. Right. What is this point? Can you tell me? According to, okay, this is a comma 0. This is 0 comma b. Okay. So that is 1. This is x-axis. Okay. Now, uh, straight line is given. Perfect. So that also should pass through the same 2 points, isn't it? Because x by a and y by b, right, equal to 1, has the same two x and y intercepts, right? Isn't it? So according to that, this is the straight line. So equation of a straight line is also given in such a way that it passes through this. Now between them means we are talking about this area, isn't it? So this is the region capital R, which is bounded between the two given. That one of them is an ellipse and one is a straight line. So my solution starts with, say, writing up the I is equal to, it's the same given equation, double integral over R, this is x, y, right? Now, anyway, let me decide that later, which one I'm going to write. So I can see that, uh, anyway, none of them is something like, yeah, so x is fixed. Sorry, I told none of them. X is actually fixed, right? I can take x varying from, this is what I do. X starts from 0. This is 0 comma 0, right? And x varies all the way from 0 till a, right? So x is fixed, right? And during that, what happens to y? I'm changing the color. Y is always between this to this. That's the y range. X is range fixed in the sense it is 0 till a, right? So that's the limit. 0 is a fixed number, a is a fixed number, like constant, correct? Right. So but you look at the y, what happens to y is, this is something like y1 of x, the upper limit is the y2 of x. You see, y is a function of x, so I have to integrate that first. Are you okay? So just recall our very first diagram when we discussed about this, right? So the concept wise, when I try to write, no, it's fine. It's absolutely fine. They have to give some way, right? So they don't have any other option. right? They cannot, when simply r is given, right? You can write dx dy dx, doesn't matter, because r is not specified, right? But when I say I am doing x is 0 to a for okay, right now I'll just write the same way which they have given, right? I'll simply write dx dy just to avoid your confusion. Hmm? But now you see what I'm writing. I'm writing x is equal to 0 to x is equal to a. Now the y actually changes from, but I cannot write, it's like y1 of x to y2 of x I should write. So from the equation of the straight line, get the value of y. So you see, equation of straight line says, right, I'll do it somewhere else so that I can come back, right? Okay, here let me do. This implies what is the y value, right? Y is equal to, because it starts from the straight line, goes till the ellipse, correct? The minimum value of the y is present on the y1 of x, which is the straight line, and the maximum value of the y is present where that is an ellipse. So I have to write the equation of y, right, for both of them. This is, I think, can I write? I directly write. Can I write b by a? Yeah, I have to write y from the straight line. Can I write b by a? This is the simplified version. Straight line, that is this side. There is no square, right? Straight line, this is a minus x. The other one, what you told is right. So y will be equal to b by a root of a square minus x square, correct? All right, so we got two equations. Let me highlight them. So those are the two values I'm going to use. One is this, and one more is this. Fine. Right. So let me just substitute those values in the as limit. So that is y starts from the straight line, that is b by a into x, a minus x minus. So a minus x, and the upper limit it should be b by a square under root a square minus x square power half, right, into simply this is x into y. Now you see dy dx. This has to be very specific. I cannot write dx dy because I am specifying the limits. Are you okay? Right, let's do the integration normal. Now that's over, just integration needs to be done. So concept is over, we applied the, yes, one of the limit has to be fixed because otherwise I'm not going to have a final answer like a constant. You're not going to get an area, right, unless and until you substitute a value, correct? So right, that's why one of them has to be like a constant. One of them you can even do the reverse, correct? What's your question? Come back, I'll answer properly. Okay. So I had two options, right? One option is that recall the previous problem which we solved in class. Okay, I gave you both options, right? I divided the board into two parts. One I wrote I is equal to, you fixed x equal to a to b, then you wrote y1 to y2, correct, into something, right, where I had to do the dy dx, right? This is because from the given graph I could understand that, okay, I let me take x as a constant, x has the constant limits, but y is a function of x. Okay. On the other side, I also did the same thing and I showed you that what's going to happen if you say y varies from c to d, right? And you can do x1 and x2 because in that case, x is a function of y. Okay, two things are possible. Yes, yes, definitely, definitely. Yes, yes, I can note that, right? Y varies from 0 to b, correct? Y varies from 0 to b. Let me change the color for our reference, right? What I do, you see, y varies from 0 to b. when y varies from 0 to b, how the x is varying, see the marking. So I have changed the color. This is how the marking will be, correct? X is like this. What's the minimum one? So whatever is on the straight line, that will be x1. Whatever is on the ellipse, that will be x2. So minimum x1, maximum x2. So you will be coming to this same notation, right? This one. Y varies from C to D, that is 0 to B, fixed value. And x varies from x1 to x2. Instead of writing the equation for y here, right? You write for x, right? So instead of writing the y here, you write this also for x. That's all. So one of them becomes x1, other one becomes x2. I hope it is fine, right? So just go back to that problem which we solved in class with the both methods, right? Just, yeah, later on you can go through that, and that will clear your this doubt. Okay, right. Okay, okay. Let us continue from here. Do you have any other doubt to clear? I can. So this is what is our equation now. I just have to solve this. So this integration. All right. So just a pure integration now. So this means I'll keep this is 0 to a for x. X as it is, there is a x. Y becomes y squared divided by 2. And should substitute the following limits. One is b by a into a minus x. And this upper limit being b by a root of a square minus x square. Right? So what I do, I'll take, there is a 1 by 2, I can take it outside, and then I'll write the limit for 0 to a, this is for x, right? There is a x, then you substitute y square as these two limits. When you write y square, the b by a becomes b square by a square. The root and square will cancel, you will have simply a square minus x square. That's the first substitution. Then I need to subtract this, the b by a into, right, this a minus x, right? So that becomes b squared, squaring, there is a squaring. So b square by a square into this is a minus x the whole square into dx. So I think you cannot see. I'll slightly move outside. Okay, now just check. Okay, so this is the complete integral. After integrating with respect to the x, sorry, y, dx is there. Is it okay? All right. So the next step, this is equal to, what happens? I just have to expand. I don't have any other thing. So b square by a square is also a constant that, and it's common here and here. I'll take that out. So this is b square in the numerator. There is a b square and 2 already present, 2a square. Then let me integrate 0 to a. So b square, a square gone out. So I can simply write this is a square x. So this is a square into x minus x into x square. So x cube minus a into, there is a x. Did I make any mistake? A minus x cube is done. Then minus, okay, this is a minus x whole square. So I can expand and multiply. So a square is there. So this is minus a square x. Then I have plus x square into x, into a minus in the outside. You see there is a x square, which is minus into x, correct? So this is going to be minus x cube. Okay, so minus a square x minus x cube. Then when I expand a minus x whole square, there will be a minus of 2ax. That becomes, there is a minus outside. Minus of minus is plus 2ax into x. So plus 2x square. Okay, all right. So there will be a plus 2 times ax square into dx. Okay, so let us try to simplify. This cancels out like this, right? Minus a square h. So only I have minus x cube minus x minus 2 a minus 2x cube plus 2ax square. I'll take the 2 out. Addition, right? Okay, so you can see that the 2 goes out and it gets cancelled with the denominator, which is 2 over there, right? I think I can simply rewrite this as, let's write this. This is b square by a square into, uh, okay, this is an integral. So integral 0 to a. So I'll write the positive term first, that is ax square minus x cube into dx. Let's integrate. So this is b square by a square into a, x square becomes x cube by 3, x cube becomes x to the 4 by 4. Limits 0 to a. All right, so that means only a comes over there. The first term becomes a cube into a, so that is a to the power 4 by 3 minus a to the 4 divided by 4 into b square by a square, isn't it? So what happens to this term? 4 minus 3 is 1. So this is a to the 4 b square divided, common denominator is 12 a square. So this cancels as 2. So a square b square by 12. Yeah, sure. I'll give you time. Okay. Okay. Yeah, sure. Please take your time. No problem. Now we'll move on to the next question. We have two more questions on this kind of problem because we have a few more varieties, right? Okay. Now, okay, this is the next question which I need to solve. So the question is solve this integral, that is double integral over the region R. And the question is now this is xy into x plus y, maybe dx dy or dy dx we can write. So where, yeah, there is a x, this is a question, xy into x plus y dx dy. Okay, you can put a bracket and where, okay, R is between y equal to x square and y equals to x. Right? So y equal to x square is a parabola symmetric about y axis, and y equal to x is a straight line, right? Making 45 degrees with the x axis or equal coordinates on equal points on the straight line passing through 0, right? Passing through origin. Okay. So let's try to draw that first. Just to understand where is this. Okay. So the y equal to x square is a parabola. We know that it's a standard one and it's a symmetric about y axis, right? So that means, right, I can try to draw something like this. All right. So this is y axis, this is the x axis. Then I need a straight line uh, meeting the required specifications. So maybe this is how it's going to look like, y equal to x. So this is a point and this is a point. Now you see, we don't have any idea. Yeah, sorry. Again, you have the complete, you can do anything, no issues. You can take any way you want. Okay, right. Okay. Now, anyway, I need to find out the points now. So this is 0, comma 0. Can you tell me what is this point? Yes, I don't. When I don't know, I have to find out because uh, that's going to be used to define my limits, right? You can take x or you can take y, but from where to where, in order to decide that, I need the point, right? So first objective is to find the intersection point, right? So to find that, I will put, see, that's a point where both the curves meet, right? So when I say both the curves meet, their coordinates, both of them should match. So what is that? That is actually the straight line says y equal to x, okay? But it also says that y equal to x square at that point, correct? So y also equal to x square. Y is equal to x from the straight line, but y itself is equal to x square from the other curve. They intersect means both of them should meet, right? So what I can do, I'll use only this part to solve for x. Then I can get the y, correct? So this means I can write x square minus x equal to 0 because x square equal to x, take x to the other side. So this implies what? X into x, x into x minus 1 outside. You cannot see the 0 written over there. Okay, so this is okay, right? So this implies the two curves y equal to x square and y equal to x intersect at 2 points, correct? That's why you have two roots here. One is x equal to 0 and the other one is x equal to 1. So when x equal to 0, that means y is also 0 because y equal to x. This means y equal to 1. This is the origin which already we have marked. This is the point required. Okay, so this is 1 comma 1. Right. When I know that is 1 comma 1, I can actually write the coordinates, right? Like this. What is the coordinate of this point? That will be, it's 0 comma 1. This should be 1 comma 0, isn't it? Okay, we got what we needed. Let's come back to the problem. All right. Now you are free to decide how do you want to proceed, what values you want to substitute, right? Now I can still do the same thing, right? One type I will solve, other type you take it as well. Okay. Now this is what is preferred, right? I can still note that x varies from 0 to 1. Okay. During this, y varies like this. Minimum value is y, minimum value of the y is traced along the parabola, right? And the highest value of y is traced along the straight line. So this becomes your y2, the lower part becomes y1, right? What is this? y1 is equal to x square. And what is y2? y2 is equal to x. That's all. So you see, you know that, right? What you should do, right? Let me write the integral just below this so that this becomes clear once again. So I is equal to, this is what I am supposed to solve. Integral, I'll write the limits as well. X starts from 0, goes till 1. Right? Then one more integral. This is for y. What is the minimum value of y? It is on the parabola that is equal to x square. Right? And it will go till y equal to x, which is a straight line. Very simple. Yeah, they have given an integral. You can simply write it. That is xy into x plus y. This is dy dx. Right? Let me write the other integral for you. This is what you are going to solve later. Okay, if at all you can see that, right? What's in this region, in this given region, what is smaller, parabola or straight line? Yeah, whichever below has a lower value. That's a lower limit. Yes, I'm writing now. Okay. Now I'm writing here. You can see that, right? I'll write the equation, which you are going to solve later, but let's write the equation today, right? Now you see, you want to say that, okay, why should I do with x, right? I'll do with y, okay? Right, so what's the minimum value of y? Starts at 0. What's the maximum value of y? That is 1, okay? Now, under this condition, you have to use, okay, let me use the strip will be like this, okay? This is my strip, right? So if that is a strip, lower value of x is present on the left side, maximum is present on the right side, correct? So that means, now I'll write, let me come back, same color, okay, now you will, because you are finding the x limit, correct? X limit means x is minimum on the left, x is maximum on the right. So this becomes horizontal. Now you tell me what happens to the x? X equal to y. No, no, left side. That's a straight line, correct? See, minimum value here, maximum value of x is found on the parabola, correct? X equal to y, right? 2, now what you told is right. So x equal to root y is upper limit. Okay, then this remains same, xy into x plus y. This is, we are doing with respect to x now, so dx dy. Are you okay? You want me to explain anything? Please let me know. I can. This is this is fine, right? Okay. So this part becomes your homework. Okay, let's solve the one which we have written on the left. So what I do, I'll multiply to, if I have two separate terms, it's difficult. We don't have a product rule for integration. So you have to go for a complicated Bernoulli's or something. Let's not go to that level. Let's keep it simple. Okay, so 0 to 1. This is x square to x. This is first term becomes x square y plus xy square dy dx. So this is equal to integral 0 to 1. I am integrating with respect to y first. So x square is taken out. Y becomes y square by 2. All right. What are the substitutions you have? You are going to make x square to x, right? Then plus the next term, x is kept outside. Y square is there. Y cube by 3. Substitute x square to x, right? So finish this, then you need to do the integration with respect to x. That's why dx. I hope this is fine, right? Let us go ahead. So this means do the integration from 0 to 1 for this. So put x over there. This is y square by 2. So x square into x square, I can write x power 4 divided by 2. And when I put x square over there, y square square, so x power 4 and x power 2, so minus x power 6 by 2. Then we have a plus sign here. Put x here, x cube and x square. This is x to the power 4 divided by denominator is 3. 1 by 3 I can take out, no issues. Okay, minus square cube becomes 6 plus 1 7. So this is x to the power 7 divided by 3. Now you see the whole equation contains only x. That's why you are going to do the integration with respect to dx. All right. Okay, let's proceed further. So this is uh, integral 0 to 1 will vanish because I'm doing the integration. So this is x to the power 5 divided by 2 into 5. So 10. This is minus x to the power 7 divided by 2 into 7. That is 14 plus x to the 5 divided by 15 minus x to the 8 divided by 3 is 24. Okay, substitute 0 to 1. So this has to be 1 by 10 minus 1 by 14 plus 1 by 15 minus 1 over 24. Okay, can you please solve this for me and give an answer? Sure. So this answer is 0.196, is it? Okay, let's move ahead. I want to show you another type of problem within this itself. So let's solve that. That will be the last question on integration over a given region R. So we want to integrate I is equal to double integration over a region, that is x square y. This function can be anything, doesn't matter. Okay, only important aspect here being identifying the limits. That's all. Okay, this x square y, xy square, x cube, y cube doesn't matter. All right. So dx, dy, where R is the region bounded by three curves: y equal to x plus y equal to 2, and there is a third curve now, that is y equal to 0. All right. Dx dy, that doesn't matter. Anyway, we are going to change it according to our thing. So where R is the region bounded by y equal to x, one curve, x plus y equal to 2, second curve, and y equal to 0, that being the third curve. We have three curves now. So within this, we need to do the integration. All right. So take your time and identify what is this given region. I think this is how it looks like because y equal to x is anyway, y equal to 0 is x-axis. That's the first axis, isn't it? One of the curve is that, and the second curve is this, right? So this is y equal to x. This is the curve x-axis. That means it is y equal to 0. And the third one, right, that is x plus y equal to 2, isn't it? X plus y equal to 2. So in order to find out the coordinate, put x equal to 0. X equal to 0 means y equal to 2, right? So this means one of the point, that is its y-intercept is 0 comma 2, correct? Put similarly put y equal to 0, that means x equal to 2. So that means 2 comma 0 will be the point, correct? So let me assume if I say this is 1, this has to be 2, correct? Very simple. Yeah, you can put y equal to x, right? So 1 plus 1 equal to 2, right? So 1 comma 1 will be the point, right? That's absolutely perfect. Okay, so this is how the straight line looks like, right? So I can extend this slightly so that you are representing everything all together. So this is 0 comma 2. This will be 2 comma 0. This is the intersection point x equal to y. So on this line, it has to be 1 comma 1, right? So this is 1 comma 0. This point is 0 comma 1. This will be the origin 0 comma 0. So now everything you got, you just need this area which we are talking about. Okay. All right. Yeah, please tell me. Which is the other side? This one you mean? Other y equal to 0 is x-axis. See, they have given y equal to 0. No height. No height means x-axis. Correct? Right. So it's because of that. It's if at all they give x equal to 0, then what you told is right. Right. If at all the equation was x equal to 0, then this one. Okay. All right. Okay. Now, is it the same problem? Is it a similar problem like previous, or you find anything differently in the method? Uh, is that so? Okay. Let's try to write as you told. Let me try to write some. Okay, I'll just write. Okay, this I will just do this. Okay. So what you are saying is okay. Oh yeah. Try to give me the integral I is equal to anyone. Any one of any method which you prefer. Uh, so integral x is equal to 0 to 2. Okay. Y is 0 to 1? Why, if it 0 to 1 is right, but is it 0 to 1 always? That's my question. Okay, let's go back to the previous question. If that is the case, you could have done y's minimum value of y will be 0 and maximum value of y is 1, right? You didn't do that. You always did between two curves, right? Are you getting the point? Right? One of them you take as it is, no problem. Other one also you cannot take, correct? Now you see y minimum. I'll draw a straight line here indicating this is my y. Okay. As you told, minimum is 0. Absolutely fine. But maximum I have to identify from this line. What is that? Y equal to x. Is it right? Okay. So 0 to first part is actually why I told first part, because now you get the answer, right? Actually, it is not a straightforward problem like the previous one, right? That is because my y has two completely different limits, right? So I divide this into two parts now, right? In this first half, this is the first half, wherein your x is only 0 to 1 and y varies from 0 to y is equal to x, correct? So x is 0 to not 2. I cannot write 2 because I have divided this into two parts. Why? Because my upper limit is bounded by two different curves. One curve, right? That's why I have to write two integrals now, not a single integral. This is the additional part which we have to apply sometimes. So x is 0 to 1, y is 0 to x, right? Do the same integral, whatever they have given, that is x square y now this is dy dx, right? X square y dy dx. That's not the answer. Plus I have to do the second half, right? And in the second half, right? So I'll just erase this. So the plus, now you see x varying from 1 to 2. In this case, what happens to y? Y once again starts from 0 because 0, but upper limit is, now you see what is the equation of this line. This is x plus y is equal to 2. So y is equal to 2 minus x. So this is 2 minus x. Once again, x square y dy dx. I hope the point is clear, right? Anyway, now onwards we'll definitely do because it's simply simple integration. That's fine. But writing that becomes the technique you use to write that becomes very important. You understood, right? Right. Similarly, you can even go for the y, right? So, what will be the equation for y? Can you tell me? If at all I want to do this is y, minimum value is 0, correct? And highest value of y being, yeah, I want you just to write the equation for y. That will be homework for you. Later on, we'll come back and we'll solve the equation we have already put. For y. Now, already we have written for x, right? X being constant. You can see 0 to 1 and 1 to 2. Now I want the other way, okay? For y. Yeah. Please take it. You just have to think of the shaded region. what is the minimum value of y you can see over there, and what is the highest value you can see over there. 0 to 1, perfect. Okay, it's not necessary always, right? You see, now this is actually easier part in this that's why you have two options always. Whichever is the easier one, you need to choose. Now you see the why this is easier, I don't have to do two parts. Okay, only when I had okay, now I'll change the color just to highlight. Okay, see, this is my strip, correct? Correct, is it, are you okay? Right, in this case I have to write what is the minimum value of x, that is the left side curve, that is x is equal to y, isn't it? What is the right side curve? 2 minus y. That's all. See, you covered it, everything. The whole region is covered. You don't have to do anything. No two parts. Simply one part. X square y d x first. Sorry, dx dy. That's all. This is going to give you the answer in this case. You see, that's why I told, right? Think of both the ways. Whichever is easier, you solve. Right? In this case, the second one is going to give you the answer quicker compared to the first one. Okay, right? So both of them you need to what you do understand, right? So writing in terms of x first and writing in terms of y first, both are important. Maybe you can practice few more problems from your question paper, right? I wanted to give some homework from your question paper today, but anyway I don't have access, right? Maybe you can find out and solve some questions at least. Maybe I'm expecting. Yeah, yeah, sure. Please get the last 4 to 5 years question papers from your. It's available in your library, as I know. My other students told. Okay. Uh, Somebody told that they got it from their some computer over there in library. Somebody told there is a printed. This thing is kept something. So some file is given, kept over there. You have to ask and you can get it print, get the xerox and you can give back. Somebody told something, I don't remember exactly what. Just find out. Okay, you get the complete set of question papers, at least 10 years. All right. Okay, so anyway, it's a straightforward problem. I expect you to solve one of them. That's sufficient. Okay, or you solve both these techniques to get an answer. I'll give you the answer, expected answer. I think that is 11 by 30. Okay, so both will get you the same answer. 11 divided by 30 as an answer. So try to solve both of them and verify your answer. All right. Okay. Later on, if you have any doubt, I'll definitely help you out to solve this. Otherwise, I think this is straightforward, right? And yeah. So the upcoming session will be on the changing of the order of the integration. Very important.